Today I will talking about new chapter for Start 101. So chapter 3 will be discussing on numerical descriptive measure. So this is the objective of this chapter. In this chapter, you will be able to describe property of central tendency, variation, and the shape in numerical data. You'll be also able to construct and interpret box plot, computing descriptive summary measure for a population, and also calculate the variance and coefficient of correlation. So let me begin with the basic definition of some measurements. So in this chapter, we're gonna focus on two main kinds of measures. The first one is called central tendency. The second one is about the variation measure or measure of variation. And lastly is about the shape of distribution. So what is measure of central tendency? So basically, measure of central tendency is the value that represent of data value. So usually there are three kinds of measures of central tendency. One of them is the mean. In real life, everybody familiar with this, but we do not call it mean in general. We call it average. So in our real situation, we have seen a lot of example that we use average or mean. For example, GPA. Okay? GPA is a mean of your score. GDP is the mean of the income of a person in a country. Life expectancy is the mean of how long you're gonna live. So usually when you have a data set, we're interested in computing some measure like mean. Okay? So we begin with we call the arithmetic mean, or simply known as the mean. Okay? So suppose that you have a sample containing several values denoted by x1, x2, all the way up to xn. So we denote the mean of the sample by x bar, and x bar is the sum of all those values divided by n. And here is the total number of value inside the sample, usually called sample size. So we may make in a short term by using this notation. We use sigma notation. So please read this as the sum of those xi, where I starting from 1 up to n. So that means we have x1 plus x2 plus x3 and so on, all the way up to xn. So this sigma notation is the shortcut for this sum. For example, we may have a data set containing 5 values, 11, 12, 13, 14, and 15. So if you want to compute the sample mean of this data set, you just get those values, which are 11, 12, 13, 14, and 15, and sum them up and divide it by the sample size, which in this case 5. Okay? And you will get 65 divided by 5, and as a result, you will get 13. So 13 is the mean of this value of this data set or of this sample. So if you notice, there's 5 values inside the data set. So the mean is actually some value in the middle. So it is in the middle. So that's why mean is called central tendency. It tells us the center of the data, right? So if you just change one of the value, for example, 15 to 20, and you recompute the mean again, we end up with 14. So in this case, the mean is no longer 13, but 14. So as you can see, even it's not exactly in the middle, but the mean in this case, just like some value inside, it stay between the smallest and the largest. So again, the mean can be considered as the center of the data. So in practice, we just view the mean as the one of the representative of the data set. So for example, if we have a group of 5 students who are 11 years old, 12 years old, 13 years old, and so on, all the way up to 15 years old, then can we just come up with a value that describe how old they are in general? Of course, you cannot say that they are 11 because only one of them is 11. And similarly, you cannot say that all of them are 15 years old because 15 is only one of them. So to compensate between the two extreme value 11 and 15, we should come up with a value in the middle between the smallest and the largest to represent that. In this case, it's good to say that in general they are 13. Okay, 13 can be viewed as the representative age of them as a group. Of course, if one of them become like let's say a little bit older, that will affect the general mean. The mean become also larger. So if one of the value become larger, it will track up the mean to a larger value. And in similar manner, if one of the value becomes smaller, it will also decrease the mean value. Okay? So sometimes if your data is not a sample but a population, we also interested in computing the mean of the population. So there should be technical difference between the mean of a sample and the mean of the population. For the mean of the population, we use Greek letter to denote the mean. So as you can see, this is the mean of the sample. We use Latin letter x bar. But when it's come to describing the mean of the population, we will use a Greek letter. So in this case, usually we use the nu. Okay? So nu is actually stand for the mean. Okay? So the mean of the population, if you have a population of x1, x2, all the way up to xn, where n here is population size, the total number of value inside the population. So we may come up with a similar procedure to compute the mean of the population. But what is different here is that we no longer use the x bar notation to denote the mean of the population. Instead, we use nu notation. So this is a Greek letter. So Greek letter just signifies that This is a measure from a population. Okay, so mean is one of the measure of central tendency. We may have another kind of measure of central tendency. It's called the median. So median is actually the value in the middle of the data set that has been ordered in ascending order. So in this case, the data already ordered in ascending order from the smallest to the largest. So you have to look for the value that stay exactly in the middle, that divide the whole data set into 50-50%. Okay? So 13 here is actually the median. Okay? Because the third position is actually the middle position, because totally you have 5 values, and third is exactly in the middle. So this third position, which is 13, is called the median. If one of the value inside data sets is modified from 15 to 20, for example, that will not affect the position of the middle value. We still have 5 values totally, and the third is still exactly the middle value. So in this case, even one of the value has been increases from 15 to 20, the mean remain the same. So in this case, you can say that the mean is less sensitive. Sorry, the median is less sensitive than the median to the extreme value. So usually when one value just become larger or smaller, that will affect the mean, but the median may not. Okay? And usually, in order to compute the median, you should look for its position first. So we have to look at the position of the mean, and usually it's come as the n+1/2 position. So for example, in this case, we have n equal to 5, and the position of the mean is 3, right? So in order to get 3, you must get 5 plus 1 divided by 2, which is 3. So the median is in the third position, right? So when it's come to compute the median, you have to care about the sample size. If the sample size is odd, this number gonna be a whole number, an integer. But if the sample size is even, when you get even number plus 1 divided by 2, you will not get a whole number, right? So for example, in this case, if you just consider one more value, let's say 16. So in this case, we have 6 value. So in this case, in that case, n+1 will become 6 plus 1, okay, and it becomes 7. And when you divide it by 2, it will become 3.5. So the median position is in the 3.5 position. So this is 1, 2, 3, and this 4, and this is 3.5 here. Okay. So in this case, the median would be the average of the third and the fourth position. In other words, the median will become 13 plus 14 divided by 2. And then our median is 13.5. Okay. So no matter the sample size it is, the median position remain n+1 divided by 2. But if the sample size is odd, we will get a good number. But if the sample size is even, this will not a good number. But in any case, even it's not a good number, you still have way to identify the position of the median and find it. Okay? And the last measure of central tendency is called the mode. Okay? So basically, mode is the value that has the highest frequency in the data set. Okay, so for example, if you have such a data set, okay, represented by this diagram, so you have 1, you have 3, you have 5 and 5, you have 7, 9, 9, 9, 10, 12, 12, 13 and 14. So in this case, if you just trying to figure out the value that appear the most inside the data set, you see that 9 is right. So in this case, 9 is called the mode because it appears most often than the other values. If your data set is in this case, we would say that there is no mode because the frequency of those values are all 1. Okay? So no numbers that has appear more than the others. So in this case, we would say that there is no mode. If you add one more value inside this data set, let's say 12, add one more 12, you will have two modes, 9 and 12. Okay? So in contrast to the mean and the median, mode may have several values and even no mode at all. Okay? So mode basically can be used for either case, numerical and categorical data. But I think it will become very popular when it's come to deal with categorical data, because for categorical data we cannot have the mean and the median. You cannot add value and divide it by the sample size, but you can figure out which value appear the most. So that's why when it's come to deal with categorical data, mode still persist while the other two does not. Okay, so let's take a look at one particular example about the computation of the measure of central tendency. So far we have 3, okay, mean, median, and the mode. So suppose that this is the house prices of a group of several houses inside a region. One of them is 2 million, another one is 500,000, 300,000, and the other two are 100,000 US dollar. So if you compute the mean, you will get 600,000. Okay, and the median in this case is 300,000, while the mode is 100,000. So if some investor interested in knowing the price of houses in this region, so as a real estate agency, which value that you should report to the investor? I don't think you will report the price of each and every house of the region, right? That should be a tedious explanation or boring description. So instead of listing down the value of those houses, we should pick up a single value to represent the house price. So in this case, which value should be a good representative of those price? So if you say, okay, in general, the house price of that particular region is 600,000. we're gonna report this to the investor so that he or she can get an idea of how expensive the price the house in that particular region. So the real estate agency may say, in general, it is 600,000. And at the same time, you may also report this value. Okay. And most also a candidate when it's come to reporting. So all of them can be considered as representative. But in this case, I think median is the best. Okay? It will give us a good representative. 600 is not appropriate because it has been affected by a large number, because general should be around something like this, not that much, right? So in order to use the mean effectively, you should make sure that there is no too large number. We mean this as outlier. There should no outlier inside the data set. So if you ignore the 2 million house, you may have something like this, and then you compute the mean again. Maybe I think in this case the mean value will be more or less similar to the median, which is a good representative. So when it's come to real practice, you have two choices to use the mean or median, up to you. But make sure that if there is outlier, mean is not appropriate. Okay, so as I said, the mean is generally used unless extreme value or outlier exist. The median is often used in the median is not sensitive to extreme value. Okay. For example, the median home price may be reported for a region that is less sensitive to outlier. In some situation, it makes sense to report both of the mean and the median. How about the mode? The mode, in some cases, it's not appropriate to represent the numerical data, but when you deal with categorical data, mode is the only choice. Okay, okay, so these three measures are called central tendency measure, and they are measure of representative. So again, if you want to pick up a value to represent the house prices in this particular region, which number would you pick up? Okay. Again, you cannot report all the values, right? This is only 5 houses. What if we have 100 or even 1,000 houses in a region? So reporting individual prices are not appropriate. Okay. So instead of saying all of those prices together, we just choose the mean or the median, which is just a single value to represent general prices. Just like when you want to see when your parent want to see your general performance of a particular semester, he or she just look at your GPA. When an investor want to see the income of a country, we just look at the GDP. When we want to see the longevity of a people or people in a country, we just look at the life expectancy, which is a form of mean. Okay, so please keep in mind that measure of central tendency are representative of data set. Okay? Now let's move to another kind of mean. So we have, okay, the general mean that we usually call it average, which comes from the sum of all the value divided by the sample size. But now we have a different kind of mean we call geometric mean. So this means just, you know, the multiplication of those values together and raised to the power of 1 over n. So this is quite different from the general mean, the usual mean, which is computed by x1 plus x2 all the way up to xn and divided by n. But this strength mean we use multiplication, okay? And in order to differentiate this with the general mean, we're gonna use x bar and use the index g. G here stand for geometry. So when it's come to deal with rate of return, we're gonna use geometric mean, not the usual mean. So for example, an investment that has a return R1 for the first year, return R2 for the second year, and so on. So we want to find the general return, the average return of that investment. In this case, you have to convert those return by adding them by 1 and apply the formula of the geometric mean. After adding those values by 1, you multiply them together and then raise to the power of 1 over n. And at the end, subtract back 1. Okay? So this is gonna call the average rate of return. You have to keep in mind that rate of return is a general term that describes the performance of investment. Basically, we have seen a lot of such thing in real life, but maybe you may not have called this. Okay, let's jump to the example. For example, if you just like consider stock price, you start with this value, and then 1 year later, the stock price decreased to this value, and another year later, it increased to this value. So if you just like compute the return, you will get negative 50%. You get this value, subtract by this, and divide it by the original value. And then, okay, suppose that you start with this value, and then at the end, you end up with this. So this means that the price has been decreased by 50%, right? And if you just now here, and then it increased to 100,000, this will be an increase of 100%. So this is the rate 1, it's negative 50, and this is the rate 2, positive 100. So we want to find out the average rate of this investment. So what is the average rate per year of this particular investment? So for the first year, you incur a negative 50% rate. Okay? In second year, you have a positive 100% rate. So if somebody asks you to find out the average rate per year, you may get them sum up and divide it by 2. And as a result, you will get 25% rate per year, right? But this is not the right result. It is a misleading result. I mean, if you're trying to compute the average rate using the usual mean formula, you will end up with 25% as the average rate, but the actual one is not 25. So instead of using the average, the usual mean, you use the geometric mean of a rate of return. So first of all, just transform each value to 1 plus. Okay? So you add 1 to each of those values and then apply the formula of the geometric mean by multiply them up together and raise to the power 1 over n, and in this case n is 2. And at the end, please subtract it by 1. Okay? So using calculator, you may see that it is a 0. Okay? So basically, if you have such an investment which give you a negative 50% for the first year and then 100% for the second year, you may say that in average you have a zero rate. Okay? So that's why after 2 years you start with 100,000 and then you end up with the same number, because in general there is no increasing or decreasing because it is 0. But if it's 25%, I don't think you would end up with this. Okay? You tend to have a higher value compared to the initial investment amount. Okay? So for example, we may use the geometric mean in rate of return in this situation. For example, you look at the stock price of some company, and you see that for the 2015, the stock price just decreased by this rate, and a year later it increased by this rate. So we want to see the general performance of the stock, right? I mean the return. What is the average return? So in this case, you may apply the same formula. Okay, now our R1 is negative 5.7 and R2 is 18.5, and then you apply this formula, you will end up with this, which is exactly 5.71%. So this case, you can say that this kind of stock has the return of average return of 5.71% per year. Okay, so when we use geometric mean, okay, I would say that when it's come to deal with rate, okay, with usual number, we use the general mean, the usual mean. But when it's come to deal with average of rate, the usual formula of the mean doesn't work. You have to switch to geometric version. Okay, you have to switch to geometric version. Okay, so this is the content that I planned for week 5, and I may try to use R to implement what we have done so far. For example, we may use R to compute the measure of central tendency, okay, the mean, the median, and the mode, and also use R to compute the geometric mean of a number of a data set. Okay, so let's move to R. Okay. Okay, I have prepared the R code to deal with the mean. So if I go back to this part where we focus on a measure of central tendency. So first of all, you have to create a data set by listing down all those numbers we have 11, 12, 13, 14, and 15 in this way, and let me call it my data. And I use this notation. Of course, you may use the equal sign, okay, or just use arrow, just mean exactly the same thing. So I call my data set my data, okay, and then in order to compute the mean of the data set, you simply use this function, okay, just use mean of, okay, just mean of my data, okay. So now let me run the data first, and then run compute the mean, and you see I get 13 as shown in the console. And this data set also have 13 as the median. So again, if you want to compute the median, you may have exactly the same word as the lecture. So median of my data, and then you run this again, you will get 13. So if you slightly change your data set, okay, for example, just update one of the value to 20, so change 15 to 20, just change 15 to 20, and then I run again, and let me compute the mean. The mean is changed to 14 as we observed from the lecture. And if I run the median, I still have the same 13, right? So here you can see that when you change one of the value to a larger number, it will affect the mean rather than on the median. Okay, okay. And when it's come to compute the mode, okay, for example, I want to consider the mode where we are in this data set. Okay, we have 1, 3, and 2, 5, 1, 7, 3, 9, something like that. So let me copy it like this. Okay, and then I may call this a different name. Let's call it data, and then I run it, and then I trying to compute the mode of the data. You may say, okay, mode of data, and then when I run this, what I expect is 9 as the mode, right? So when I run it, I get numerics. So this means that mode is not the mode that we actually meant in the lecture, right? So if you want to compute the mode, which is in this case 9, you cannot use this function. It gives us something different. Okay? So in order to compute the mode of a data set, you have to install a new package. You need additional package to compute the mode. Okay? The package name modis. So usually when you want to install a new package, just use the command install.package and put name the package you want to install inside code, right? So then just run this. You are ready to compute the mode, right? There are several ways of installing new package. You may search Google on how to do so. And once you've done this, I think you better just get rid of it. So in order to avoid reinstall it again, I put a hashtag to tell us that this is just a command, not a code to be executed. So once you install it successfully, you have to call it into use by using library and put the name of the package you just installed. If you don't call it into use, you cannot compute the mode as planned. Okay? So before you can compute the mode, just call this package into use by using library and put the name of the package. And then suppose that this is your data set. So the mode of a data set come by MFV, not mode, okay? Because mode of data doesn't work, as you already seen, okay? So we do not use mode of data. Instead, we use MFV of data. And MFV cannot be run if you do not install this particular package, right? It needs this particular package in order to use MFV. And then when you run it, you will get 9 as expected. Okay. So if I add one more 12 to our data set, I expect to get 2 modes, right? 9 and 12. So let's see. After updating the data, I run MFV of data again. See, I get 2 values, 9 and 12 as the mode. So this is, you know, the way to use R to deal with computation related to central tendency measures. Okay, I asked everybody to do more exploration on how to use R to deal with geometric mean. Okay, it's a little bit challenging, but I wish I just like encourage everybody to explore, okay, rather than just show you. Okay, so I end the lecture of week 5 here and hope you find it useful.